On this problem, we're going to try to find the power absorbed by each element on the circuit. First, we need to write Kirchhoff's voltage law around the loop. We select the current I sub A in the clockwise direction. The first element is the voltage, so we write 12 equal to A times the current plus 3 b sub x plus 4 times the current minus b sub x. Second, we need to find the equation for the dependent source that's across the 12 ohm resistor. And so b sub x is going to be equal to 12 times the current. Current goes in opposite direction, so that's going to be minus 12 I sub A. Third, we put everything together. And then by solving and putting the value of b sub x into the equation, we find that the current is going to turn into 12 volts equal to 24 I sub A minus 36 I sub A, where I sub A is going to be just 12 divided by minus 12 is minus 1/2. That means current I sub A actually flows in the opposite direction. So if we write our current in the opposite direction, then we can find power starting by the 4 ohm resistor. Power is I squared times R, and that is going to be power entering the positive terminal is going to be 4 watts. Power across the 12 ohm resistor is going to be I squared times R. Current enters the positive terminal, so is I squared times 12 equal 12 watts. The next element is the voltage source, and that's I times B. The current enters the positive terminal, so that's going to be 1 amp times 12 equal 12 watts. The next element is the 8 ohm resistor. Current enters the positive terminal. I squared times R is going to be I squared times 8 equal 8 watts. Sum of the powers absorbed is 36 watts. Now we're going to look at the dependent source. The current enters the negative sign, so this is going to give us a negative value. And so it's I times minus 3 b sub x. B sub x is minus 12 I sub A. I sub A was in the opposite direction, so we put that value into the equation. So power of the 3 b sub x is minus 36 watts. And now summation of powers absorbed is equal to summation of power delivered. And that's the solution to the first problem.